Welcome to our video session on bridging platforms, enhancing your development workflows with Parallels. Today, we'll be exploring seamless development across multiple platforms, leveraging the power of Microsoft tools, Apple Mac, and Parallels Desktop. In today's software development landscape, where versatility and efficiency are key, Parallels Desktop offers a bridge between the Microsoft and Apple ecosystems, allowing you to harness the capabilities of a robust development environment. Due to its power, the Apple Mac platform has become increasingly popular amongst developers, and Parallels Desktop allows you to utilize your favorite Mac OS applications while seamlessly integrating Windows-only tools into your workflow, giving you the best of both worlds. Parallels Desktop is the only solution authorized by Microsoft to run Windows 11 directly on a Mac with Apple Silicon, and it's also certified by the ARM System Ready program. So whether building applications, testing software, or deploying solutions, Parallels Desktop empowers you to work smarter and not harder. Today, we're going to be exploring the following themes: developing Windows apps on a Mac and running Windows on ARM, cross-platform development using the 𝗦𝗲𝗀𝗻𝗻 framework and the advantages that Parallels Desktop can bring there, and using the Parallels Desktop DevOps service to orchestrate and automate workflows. So, let's dive into developing Windows apps on a Mac. To show how you can use Windows ARM on a Mac using Parallels Desktop and how you can build and test for different platforms, we have here the latest MacBook Pro with the Apple M3 chip running the ARM operating system macOS Sonoma. One of the coolest features is the ability to run a Windows virtual machine on it with the help of Parallels Desktop for Mac. Inside the virtual machine, we have the Windows ARM version running. And we can even use Visual Studio to build legacy Windows applications or applications that are built for the Windows for ARM platform. Let's take a closer look by building the Notepad app. Once built, we can look in the Task Manager for the Notepad application, and you can see here that it is an ARM64 in the architecture column. But also with Windows ARM, you can build targeting the x64 platform as well. By switching to the x64 platform and rebuilding Notepad, we can see in the Task Manager that it's now built for x64. This demonstrates the versatility of running Windows ARM on a Mac using Parallels Desktop and with the ability to build and test for different platforms. We are now going to demystify how we can build cross-platform applications using a Mac, and then test that application in different operating systems, including Windows. For this, we're going to use the .NET 𝗦𝗲𝗀 framework and show how we can build this in Windows using Visual Studio. For people that don't know what 𝗦𝗲𝗀 is, it's Microsoft's approach to building native cross-platform desktop and mobile apps all in one framework from a single shared codebase. Microsoft provides you with some samples, and we'll use one of them in this example. We can go to the open source repository on GitHub, where we're just going to clone this for our own use. And once cloned, we can quickly access the application that we want. In my case, we're going to use the weather application, which is in this folder, and we can open it directly into Visual Studio Code. I already have a profile for Visual Studio Code to use 𝗦𝗲𝗀𝗀, and you can see that it already contains all the dependencies and sessions needed for debugging. If we open my program, we'll be able to debug it in different targets. I also have all simulators for iPhones and Mac and have Android in here as well. But to show this as a Mac app, I just select my Mac, quickly press F5 to start debugging, and the application will then start compiling from my Mac. As you can see, everything is working in Mac's native language. I can open and check everything I need to use that application, and I could debug it with breakpoints or whatever I need. Now, while this is great, we may want to use Visual Studio instead of Visual Studio Code, which has some advantages in the 𝗦𝗲𝗀𝗀 case. The 𝗦𝗲𝗀 extension in Visual Studio Code while great at the moment, lacks some advanced functionalities like hot reload, which to a developer, when you're trying to change something and you can't see that change immediately, especially in UI development, can be a bit annoying. So how can we solve this? We could use Visual Studio, which does contain hot reload for MAUI applications, but we're using a Mac here. Well, this is where Parallel Desktop comes in. We can run a virtual machine with Windows, install all the tools that we need to build MAUI the same way as we have on our Mac, and then build the application for Windows. We already have a virtual machine prepared for this. We're going to use our extension to start the specific machine. This is the Parallels Desktop extension that works really well within Visual Studio Code. And we have here our MAUI development virtual machine that we can start up. You can see the 4 squares icon in the taskbar showing that the machine is now running. So we can go into that Windows operating system and start Visual Studio. Then we can load our weather application and compile it here for Windows. So if we press the Start button, you'll see the application is compiled in Windows and running inside of our Mac. You can see that the application looks different to when it's compiled as a Mac application, and that the location menu items have a different layout. Running the MAUI app inside of Visual Studio on Windows means that we now also have the benefit of a hot reload, which means that if we try to change a file, for example, if we change the location text in the menu from change location to not change location, the application will automatically reload and our menu title is changed. This is a functionality you will not have in Visual Studio Code for now, so having our virtual machine with Visual Studio on it also brings you the advantage of hot reloading the changes that you just did and testing it and seeing if that works or not. In conclusion, using Parallels Desktop on Mac, we can develop this type of cross-platform application, and we can still use Visual Studio to do the development. We can test the same changes in our iOS, Mac, Windows, and Android devices to make sure that they work there as well. One of the advantages being that for the UI on our desktop application, it can be quite different from the UI on our mobile application. So testing it on all devices does make sense. With Parallels Desktop, we're able to provide one device that can do everything you need as a developer, hence breaking all of the barriers that we had previously had. Parallels Desktop comes with the optional DevOps service. Once installed, the DevOps service allows you to automate and orchestrate workflows that include multiple Mac computers and the virtual machines. The service has several roles that can be enabled, including REST API, Orchestrator, and Catalog. The REST API, along with command line interface, gives you the most versatility and control. However, Catalog and Orchestrator roles are also ready to use and can be integrated with your CI/CD workflow to build and test software in Windows, Linux, and Mac OS virtual machines on your Mac devices. Here you can see an example of a GitHub action that can use the DevOps service, and this is readily available in the GitHub Marketplace to be used on-premise or on hosted Mac devices. Also in the Parallels GitHub repository are other open source projects for use with Parallels Desktop, including our Visual Studio Code extension that we saw earlier, and we encourage you to create your own projects and add to them in there as well. So, develop, build, and test with Microsoft, Apple Mac, and Parallels. We're looking forward to see what you can build.